Okay, in this video we're going to talk about cross-sectional solids again. Just remember that every cross-sectional solid is going to be the integral of s squared dx, where s is equal to, always equal to upper minus lower. They're actually easier than the rotational ones, but depending on the type of cross-section, and they'll always tell you which type you're dealing with, there may be a constant out in front here. So the question is, which constant goes in front with each thing? In this video, I'm going to show you where the constants come from, and then talk about a shortcut to remember each of those constants. So all I'm going to do is start drawing shapes and label the bottom of it S, so we can come up with a constant that may give us the area of the face. This number just has to be the area of the face of the cross-sectional solid. So the first one we're going to talk about is going to be square. If the base of the cross-sectional solid is S and it's a square, and square I think is the simplest, that will remind you, that means the other side is also S. The area of this face is S squared, and therefore the volume is equal to the integral of S squared dx, because dx will end up being the thickness of that piece right there. That's why square is simple, because it's just S squared. It's the simplest one of all. The next type will be a rectangle. That's that rectangle. And they'll always give you some information about the rectangle, and they'll give you information such as the height of the rectangle, length times width, sorry. At the length of the rectangle, let's call this S. The height of it is 1/2 of the length. They may tell you 2, they may tell you 3, they may tell you 5. I'm actually going to take that 1/2 out and say it's n times the base, ns. The volume of this is then n times s squared. So the integral we get is n s squared times the thickness, which is going to be dx. But I don't like to keep that. N is a constant, but it's whatever times they tell you to work with. So let's not work with it though. Let's put the n outside, so it becomes n times the integral of s squared dx. So basically whatever time they tell you the side is compared to that, you put that number on the outside. You take s squared and you multiply it by that. And those are the two easiest ones. Now we're going to talk about parts of a circle. A lot of times they'll tell you the base forms a quarter of a circle. So if this base is S, right here, then the volume of a circle, that would be the radius of the circle, then the area of that section, the area of the whole circle, if I took the whole circle, would be equal to pi S squared. Because I want 1/4 of the circle, it's going to be 1/4 s squared. So that's nice and easy. That means the volume. This is going to have the thickness of dx. It means that the volume is going to be the integral. I put all the constants out front. I can put them inside so much easier out front though. 1/4 pi s squared times the thickness, which is dx. So if it's a quarter circle, quarter pi goes on the outside. Because look at that, that's a quarter pi. So now let's talk about a 1/2 pi. And I know what you're thinking, it might be bigger, but it's not. S is the base. So S is the whole diameter. So what happens is the circle doesn't quite go up as high as it did before, because the radius is not S. The radius is 1/2 S. So the area of the face of that is equal to pi times the radius, which is 1/2 s, squared. So for this particular section right here, so for the whole circle this would make up, it would be pi 1/2 s squared. So the area of the whole circle would be pi, got to square each part, and be 1/4 pi s squared. But because there's only half the circle, I have to multiply it by half again. And I get 1/8 pi, the integral of s squared dx. So for a 1/2 pi, the area is, this is the constant that goes out front, 1/8 pi s squared. What I think about it is if I wanted to eat a quarter of a pie or a half a pie, I'm going to eat, or I would have, I'm sure I could sit down, I ate that whole half a pie. That's why it becomes 1/8 out in front. So the difference is a quarter pie is going to be taller, so it's going to have more area, whereas a half pie is going to be flattened out as we go. So those are the two circular pieces we get, and the other three are triangular pieces. And there's three different triangles we get. And the first two types, I'm going to do them both on the same page, are isosceles right triangles. But depending on the isosceles right triangle, you may have an isosceles right triangle where, and they'll describe it in different ways. The angle is above the base, which will look like that. Or they'll say the hypotenuse makes the base. Or the other way to look at it is the right angle is on the axis. So it'll look like this. In which case this is S and this is S. So here I see 1S. And here I see 2S. And they all determine different things. So what I would have to do is I remember the area of, it's going to be the area of the face times dx. Same thing on this one here. So what I have to do is find the area of the base. Sorry, area of the face. I said base, I didn't mean to. So the problem is, I don't necessarily know what it's going to be. Well, if I draw this line here, I know it's 1/2 base times height. And it's 1/2 base times height. So on this triangle, second triangle, I know I did the second, I'll show you why it's pretty straightforward. It's going to be 1/2 the base, which is S, times the height, which is S, which equals 1/2 S squared. I'm going to write it differently. I'm going to write it as 2/4 S squared, and you'll see why in a minute. So if that's the area, and the volume is 2/4 S squared dx. Let's come back to this one. I've got to split this down the middle. I know that this was a right triangle, and I divide it in half, so this side is 1/2 S. If this was 90 degrees, this is 90 degrees. Now, if I divide this in half, this is 45. That means this has to be 45 as well. You never have to reproduce this. I'm just showing it to you once. So that means this side here is 1/2 S. So 1/2 base times height is 1/2 S. Not that, 1/2 the base, which is S, times the height, which is 1/2 S. Multiply all those together, I get 1/4 S squared for the area. So the volume is the integral of 1/4 S squared dx. Why did I write them this way? How many S's were on this triangle? 1. So it's 1/4. How many S's were on this triangle? 2. So I got 2/4. Leaving me for my last type of triangle, which is an equilateral triangle. Which means that all three sides, including the base, are the same. So if this is S, then this is S, then this is S. But this is not a right triangle. But what I do know is it's still 1/2 base times height. So it's 1/2 the base is equal to S. Now I've got to find the height. Well, that's going to be tricky to find, except that this is a right triangle. That's S. This cuts it in half. That's 1/2 S. So that'll allow me to find the height of this triangle. So I'm doing a little work, but I don't have to do this every time. I just need to know it for this one right here. So I know that I use my right triangle formula. A squared plus B squared equals C squared. I know that 1/2 S squared plus, we'll call this X. X squared equals S squared. Let's solve this out. This is 1/4 S squared plus X squared equals S squared. And I'm going to get X by itself. I'll subtract 1/4. S squared. X squared equals negative positive 3/4 X squared. Spare both sides. x equals the square root of 3/4 times s squared. Why did I leave that one this way? Well, this one was not a right, doesn't have a right angle in it, so it's a little different. So it's a radical one, but it had 3 s's, and that's why I used that equation to solve that one. So this side, we just found this side. There's a lot of work. Once we find it once, we have to find it again. That side is equal to radical 3 over 4s squared, or that side is equal to radical 3x equals radical 3 over 2x. That's that side right there, radical 3 over 2x. So in black now, I'll find the area. It's 1/2 s, which is the base, times the height, which is radical 3 over 2. Sorry, s, which is equal to radical 3 over 4 s squared. So the volume is radical 3 over 4 s squared dx. Why does this one mark for that? This one has 3 s's, 1, 2, 3. That's why I have the number 3 in there. But he's a radical triangle. He's not right. There's something not right about this guy. He has no right angles in the triangle, so he's radical. That's why he gets a radical 3 on the top. That's why I can tell these particular triangles apart from each other. So I'll lay out the exact rules on a sheet of paper for you, but this is where they all come from.